Okay, so this is what I posted on Google Classroom, just as a reference. Okay. And again, this is a little bit of review, but we are going to get a little more into factoring, right? Factoring trinomials and things like that. We did this in Algebra 1, but we're doing this again. We're starting off with the most basic ones, and then we're going to go with the ones that are a little more difficult. Okay. But at least for today, we can start with this. Okay. Now, when we're looking at factoring, something like this is a quadratic equation. Okay. So a quadratic equation, when you graph it, is going to look something like this, right? Like a little U shape. Okay. If you notice, there's 2 times that it crosses the x-axis. Okay. We call those, well, obviously we call those the x-intercepts, but there's also another word for them. We call them zeros, right? So the whole idea here is that we are looking for the zeros of this equation. And we'll see how that looks like a little bit later on, hopefully if we're back in school tomorrow. They haven't told us anything yet, but. So the thing that we're gonna do is we're gonna start off by focusing on this last number right here. Okay. So what we're gonna do is I want you guys to give me the factors. What are the factors of 6?
Two.
Right. So, and you can always start off with 1, and 6, right? Because 1 times 6 is going to give us 6. What about, and you said, Lindsay, 2. 2 times what?
4. 2 times 2.
Wait, to get to 6.
Oh, 3.
3. 2 times 3. Okay. That's pretty much it, right? So 1 times 6 gives us 6. 2 times 3 gives us 6 as well. And those are pretty much the factors. So what we're looking to do is we're looking to see which one of these 2 is going to add up to this middle number right here, to 5. So looking at this, which ones add up to 5?
2 and 3.
2 and 3, right? 2 and 3 both add up to 5. So our factors there, our zeros, are 2 and 3. So how are we going to write this? We're going to have x plus 2, x plus 3. And that's our factored version of the trinomial. Okay. Of course, we can check that, right? If you guys remember what we did, what we were doing earlier, we were multiplying the 2 things together. We can check it that same way, right? So x times x, that gives us x squared. X times 3 gives us 3x. X times 2 gives us 2x. And then 3 times 2 gives us 6. And if we combine those like terms, we would have x squared plus 5x plus 6. So basically what we're doing is the same thing, but in reverse, right? So instead of multiplying, now we're factoring. So we're doing the opposite of it. Okay. Okay, so now let's look at example 3. Where we have 14. So what are the factors of 14?
1.
So we always start off with 1 and 14.
2 and 7.
2 and 7. And I think that's it. Right? So here's where it gets maybe a little bit different, right? We have a negative 14. So what does that suggest? If we're multiplying, what does that suggest for one of our numbers here?
has to be negative.
So one of the numbers has to be negative, okay? But at the same time, we also need to make sure that we're adding up to a positive 5x. So which ones would give us a difference of 5?
2 and 7.
2 and 7, right. So 2 and 7 would give us a difference of 5. Now we need to decide which is a number that we are going to make negative.
Wouldn't it be 2?
It would be the 2. And here's why, right? Negative 2 times 7 gives us negative 14. So we got that, right? We multiply those two. But if we add them, 7 plus negative 2, or we can say 7 minus 2 gives us a positive 5. Okay. So we're going to write this as x plus 7, x minus 2. And that's our answer.
This is easy, sir.
Good. Let's see. A couple other examples. So what about something like example 5 now? Okay. Now that one's a little unique, right? Because we have that 1. I mean, what are the factors of 1?
1.
Exactly. 1 times 1, right? But the problem there is, does it add up to 5?
No.
So we would call this prime. Okay. In other words, we can't really do anything with it. It's just that, prime. All right, let's see. Okay. Let's go with this one, with 12. What are the factors of 12?
1 and 12, 2 and 6.
1 and 12, 2 and 6.
3 and 4.
3 and 4. And I believe that's it, once we get to those. So these are our factors of 12. Now, which ones are going to add up to that positive 13?
1 and 12.
1 and 12, right? Right there. These add up to 8. These right here add up to 7. Okay, so 1 and 12. Now, I guess what's a little bit different here is just that exponent, okay? That x to the power of 4. Really, the only thing that does is that it changes the way that we're going to write our answer. So instead of just a single x, what we're going to write is x squared. So x squared plus 1, x squared plus 13. And, you know, of course, we can always check just to make sure, right? But let's see. X squared plus 1, x squared plus 13. So x squared times x squared, that gives us x to the power of 4. And we got 13 times x squared times 1, and 13 times 1, which is 13. Well, actually, I wrote that wrong. It should have been 12, right?
Yeah, I was going to say.
Well, just going to change all these numbers to 12. 12. Okay. Should have been x squared plus 1, x squared plus 12. So then x to the power of 4. And 12x squared plus 1x squared is 13x squared. And 12. So again, not too much of a difference. I mean, the process is still the same. We just need to decide how we're going to write out our answer. Okay. Now, one of the things that we haven't had to do, especially because we don't have a number on the outside right there, is that usually the first step that we want to do is we want to factor out a common denominator before we actually start factoring like the whole thing. Because for example, it becomes a little bit more difficult when we have a number in front of the x squared. If you notice, all the examples we've had so far had only a 1 on the front, right? So what we want to do is, again, get to a 1 outside on the x squared, right? So we can factor out from these numbers. So if we factor out the 4, we're left with x squared. And what does 24 end up as? Because we're factoring out a 4. I guess it's the same thing as saying the 24 divided by 4.
I don't understand. What?
What we're doing is we're factoring out the 4 before anything. So you see that 4 that's in the front of x squared? We're factoring that out. So if we take that out of this trinomial right here.
So wouldn't it be 6?
Right. So 24 turns into 6. And then what about 36?
Wait, we do the same thing?
Yeah.
So it'd be 9?
9. Okay. So yeah, basically all I did here was I factored out that 4 because it makes things a little bit easier now. Like I said, we always want to have a 1 in front of the x squared. That's the easiest way that we're going to be able to factor. Okay. So right there, we just factored out the 4. Of course, if we put it back, if we distribute it back, that's like saying 4 times 1, 4 times 6, 4 times 9. The same thing, right? So we just did the same thing, but in reverse, right? We took out the 4. We took out the 4 over here. We took out the 4, right? But anyways, now that we have that 4 on the outside, let's focus on what's on the inside. So what are the factors of 9?
Obviously 1 and 9.
So we always start with 1 and 9, of course. That's what we always want to do.
3 and 3.
3 and 3. And I believe that's it, right? So 3 and 3. Now, if you guys notice, the 9 is positive, okay? But the number in the middle is negative. So what do you think that means? How do we have to write out our answer? So remember that they had to multiply to a positive 9, but they need to add up to a negative 6.
So the other 3 would be negative.
The other 3?
Yeah, not the second one, the first one.
Well, if we only did the second one, that would be, so you're saying like this. It would
Oh
be
no, wait,
negative.
because you're adding. Oh, wouldn't it be both?
Both?
To
So
give you a
both?
positive 9, you have to have a
Right.
positive 9.
So if you multiply negative 3 and negative 3, right, that gives you a positive 9. But when you
Yeah.
add them together, that gives you a
Negative
6. Good. So we're going to have x minus 3, x minus 3, which is one way of writing it. But since we have two of the same things, x minus 3 and x minus 3, we can rewrite it another way, right? We can say x minus 3 squared, and that's our answer. This is the exact same thing, right? Remember when we're looking at, for example, like x plus 4 squared, right? We're not actually distributing that square, right? It's just writing this as x plus 4 times x plus 4. Okay. That's it.
Oh, I see it.
Yeah. So it's it's basically the same thing. It's just again, just the way that we're gonna write out our answer. And of course, we keep that 4 on the outside because it never goes away, right? We factor it out at the beginning, so the 4 just stays the same right there. Okay.
Are you giving us work on delta math for this?
Yes. These should be, I mean, these should be pretty easy. Okay. These are easy grades that I'm trying to get, especially at the beginning. Trying to decide if we should work on an example, or you guys should work on an example.
What do you mean? We have been.
But just you guys. Let's see. Like for yeah, let's do 8. And now the only thing here is that it's written out of order. So if we write it the way it's supposed to, it should be x squared minus 14x plus 48. Okay. So what do we?
And 48. You have to
Right.
find the factors of 48.
So let's go ahead and start with the factors of 48.
1 and 48.
1 and 48. And, you know, usually I go like with a calculator. I just start like, okay, 48 divided by 1, 48 divided by 2, 48 divided by 3, 48 divided by 4. You know.
So 2 and 28.
2 and
No, 2 and 24.
24. Yeah.
I don't know what's for 3.
Yeah, so like I said, in the calculator, it's just like 48 divided by 3.
16.
3 and 16.
4.
48 divided by 4. 4 and 12. I'm gonna write them up here because I'm running out of
That's
space.
it.
Is that it?
Yes, sir. Because 5 would be like 9 point something.
But then we can do 48 divided by 6.
Oh, yeah, 6.
6 and 8. 48 divided by
8 is 6.
Yeah. So once I think that's the way that you know how to stop, right? Because once you meet up with the other factor, like 8, that's like right in the middle, right? It's like we're starting from the outside until we meet at the middle, which is 6 and 8. Once we get there,
Because it repeats, basically.
because everything else is just gonna repeat. So now we need to decide. Okay, so we have our factors of 48, which is quite a bit. So we need to decide which ones of these are going to give us a positive 48, but they also need to add up to a negative 14. So let's start with that. Let's start with which ones are going to add up to 14. So we have 1 and 48, that adds up to 49. So obviously not those.
6 and 8 would.
6 and 8 add up to 14, right?
Mm-hmm.
Because 4 and 12 is 16, 2 and 24 is 26, and 16 and 3 is 19. Okay. So it's going to be 6 and 8 that add up to, or multiplied to, sorry, add up to a 14. But it needs to add up to a negative 14. So what does that tell us?
That one of them needs to be negative.
Okay, but well, if one of them is negative, that would give us a negative 48.
Oh, well, we needed a negative 14 and a positive 48. So both would be negative.
Both would be negative. So they add up to negative 6 and negative 8 add up to negative 14.
But positive 48.
And multiply to positive 48. So our answer here is x minus 6, x minus 8. Cool. All right.
That was easy.
Good. So yes, it should be sort of like a review